Now let's look at this figure 17-22 that deals with grounding high voltage systems in accordance with the requirements of 250.180. Now notice shields is something that we have to ground properly. Now we get started grounding these shields in note 2 when we reference 311.60C as in car 1. But the additional grounding of shields sections that we need to review is 300.40 and 311.44. The transformer you see outside the building is connected to a driven rod in accordance with 250.66A of the code. Usually this grounded conductor coming in to return short circuit current is sized from our table 250.102C1. The equipment grounds that you see, or I shouldn't say equipment grounds, pardon me, the grounding electrode conductors that are connected into the driven rod are sized from table 250.66. Or you would go to table, or not table, but 250.66A. The table would be used to connect to the water pipe. Now make note that the table 250.66 is only used when you ground with a grounding electrode conductor to a metal water pipe or to the structural steel. If you're grounding to a driven rod, it's 250.66A. A concrete encased electrode is 250.66B, as in boy. If it's a ground ring, it's 250.66 and 250.52A 4, I believe it is, that you would look at. Now, what we're trying to do here, when you run the equipment ground over here, then that's table 250.122. And the equipment ground would be sized off of this breaker that you see on the panel board. And if you developed a short circuit, it would return over your equipment ground back to the grounded bar that you see in the service equipment, travel over the grounded conductor back to your transformer, return on the phase it went to ground, and localize your fault. And you know, we have some rule of thumbs that we use for that if you wanted to get into volume 1 of Stallcup's electrical design book that gives you some tips. And of course, any metal raceway has to have a bonding jumper, equipment bonding jumper, as you see in the illustration to your right there. So basically, this is what this illustration 17.22 is illustrating in accordance with grounding high voltage systems and complying with 250.180. But now notice for lightning protection, diverting surges, lightning protection, and things of that nature, you'd want to review 250.4, A as in apple, 1. And then if you high impedance ground, in other words, you're going to put a high impedance ground in your grounding system somewhere, then you'd look at 250.187. Now I think that pretty well covers what this figure 17-22 is trying to point out to the user of the NEC.